Our next topic is geometric vectors. Geometric vectors. So remember, geometric means pictures. We're going to be drawing some pictures, and we're going to be solving them. So learning goal. I want you to be able to represent and draw vectors graphically and perform the resulting operation required in order to determine magnitude and direction of the resultant. So now I have a new key word. I'm introducing a word inside our learning goal here, and that is the word resultant. So we need to talk about what is the resultant before we get to the triangle law here. So off to the side, the resultant is the sum/difference when two vectors are added or subtracted. So as soon as you see the word resultant, right away in your head you're thinking, okay, this means I'm going to be adding or subtracting a pair of vectors or more. All right. How do we do adding and subtracting vectors? Well, geometrically, and that's what we're looking at today. We are looking at the triangle law. So that's our first law that we're going to talk about. Triangle law of vector addition. Okay? This gives you a process to add geometric vectors. So we're adding or subtracting two vectors. So keep in mind, this process is only good for adding two vectors at a time. Step one, draw the two vectors head to tail. And I can't stress this enough. You can talk to the vector, people who are taking vectors, people who are doing the physics. You need to do head to tail or this does not work. So what do we end up with to start with? So originally we will end up with two vectors that look like this. So this is the starting point. This is before I actually do step one. So there we are. So step one, I'll indicate that with a 1, obviously. We arrange the vectors head to tail. So we're going to redraw this. So you want to watch this before you go ahead and draw your own. So moving them around. Woo, wee, hey, it bounces. Look at this. Okay, enough fun and games. Vector U, I could arrange it head to tail that way. So that means arrow to the end of a vector. Or I can take the other vector and do it over here. It doesn't matter the order. You cannot screw this up as long as you draw them in the same direction. Now, I'm used to doing it this way. Like I said, it doesn't really matter. So now I'm just going to indicate I have vectors U and V. So there's step one. Step two, the sum or the resultant is a vector that's measured from the tail of the first vector. So your starting location. It's like a map. This is where I started. Okay, so that's my start, S for start. And that's at the tail of the first vector. And I'm going to end at the head of the other vector. Whoops, B. I don't know what that stands for. We'll go E for end. So this is my resultant, and the resultant we use an R for. Okay? So we have our start and our end. All right? So if you were going on a trip and you went down the U vector and then the V, the resultant would be as the crow flies, if you want to put it to a old statement that you likely heard your grandparents use. Okay? So the resultant, to solve resultant, I'm just going to add this down below. Oops, to solve for resultant, we must use, and this is the order, first step would be cosine law, second step, sine law. Okay? So we are going to be using cosine law once and sine law once when we start solving these questions. All right? So, need some examples. That's the only way this really works or helps out. Parallelogram law, what I'm going to do is, if you have trouble with the triangle law, I'm going to come back and talk about parallelogram law. So don't, we're not trashing this slide. Triangle law and parallelogram law are really the same thing, but sometimes parallelogram law will help people that visually can't see it. So if you need assistance, I will introduce you to parallelogram law in class if I feel like it's a situation that you need it for. Okay? So if you're struggling with this and I see that you're struggling, I am going to show you this other method. Okay, so here's the first example. No picture. No picture is great because you can draw the vectors however you want. If u vector, magnitude of u is 10, magnitude of vector v is 5, and the angle between the two vectors, when they're placed tail to tail, is 30 degrees, we want to find the resultant. So that means that we are going to be doing, the resultant is equal to u plus v. All right, so this is where I always recommend putting the two vectors. If you're allowed to draw your own picture, draw one vector horizontal. Doesn't matter which one. So I have done vector u, and the magnitude is 10. Magnitude is v is 5. It's 30 degrees. All right? It just helps us wrap our heads around if one of them's horizontal. I don't know why, but people are much, much better at this when they do one of them horizontal. So it's always nice when you can draw your own picture. Okay, so when you're looking at this question then, you got to rearrange it. You have to use your triangle law. Please do not do this. So many people jump right to wanting to go and solving the triangle. You must rearrange the vectors head to tail. It has to be head to tail. Okay? So underneath, this is what you're going to do. We're going to rearrange it. You're going to take your vector u, and you're going to redraw it down below. Okay? So you can drop the vector notation. You know the magnitude's 10. We need to write it head to tail. So we are going to take vector v, and I didn't want to do that whatsoever, and we put it at the head of the first vector, and we know the magnitude is 5. Now we can draw in the resultant. The resultant is this vector right here. Okay? Head to tail addition, there is the triangle, hence the triangle law. Here's the catch, here's the trick. Okay? What we did, and if you're looking up at my diagram here, what we did was we slid this vector down to this location here. Okay? So I'm going to return the original back here so it doesn't mess up my picture. So what that does is it slides that angle with it. So this stayed 30 degrees, which means when we go down to the picture below, because we just slid that down, that's 30 degrees. If that's 30 degrees, then the angle inside the triangle will be 180 minus 30, so that's 150 degrees. All right, so now we have interior angle and we have two sides. Guess what? We have enough for the cosine law. So cosine law, if you recall, a squared equals b squared plus c squared minus 2bc cos of angle A. Okay? That's not what you're going to put on your cheat sheet. This is what you're going to put on your cheat sheet or your formula sheet for the exam. Magnitude of my resultant, which is just the A value, equals square root. I've took the square root of both sides to get A by itself, so that's my resultant. It'll be the magnitude of u squared plus magnitude of v squared minus 2 times magnitude of u, magnitude of v, cos of the angle. This is the formula you're going to put on your cheat sheet. Okay? This will find the magnitude of a resultant for any geometric vectors. It's just from, it's cosine law. I've just changed the variables for you. So for our question, magnitude of resultant, you need to have those magnitude signs, is equal to square root of, what's the magnitude of u? Well, that's 10 squared plus magnitude of v is 5 squared. So it looks exactly like the cosine law that you're used to. It's just that initial formula that looks a little bit funky. All right? So now you're going to have to go through and use your calculator. I'm going to be looking at that line. I'm marking process here. So if you make a mistake in the next line, at least if you have it set up right, you can still get some marks. So 20 times 5 times. And if you want to double check with your calculator, please, to make sure you do this properly. So 100 plus 25. You should get the square root of 211.6. And take the square root of that. You get 14.5 units. So there we go. We now know the length or magnitude of our resultant. So remember on the previous page I said you're going to use cosine law. So that's done. Now you use sine law because resultant is a vector. You need to know, or you need to find the angle. We need to know that angle in order to finish this question. How do you use it, or how do you find it? You need to use sine law. So we know that sine A over side A equals sine B over side B, which is equal to sine C over side C. That's not the formula you're going to put on the cheat sheet. You are going to put the sine of angle A, which is from up above. Okay, that's the 150 degrees over the magnitude of the resultant, equals, and in this case we just need to know the sine of theta, that's what we want to find, divided by magnitude of V. All right, and that will find the angle of the resultant for you. And I can rearrange it for you if you want. So technically, if I do a full rearrange, theta is equal to sine inverse. You need to be careful with this. Make sure you plug it in properly. Magnitude of V, sine of angle A, divided by magnitude of R. Now, this is only going to be true for when the vectors are horizontal, and we'll do an example where they're not, and you can see the adjustment that needs to be made. So either of these formulas you'll want to put onto your cheat sheet. So to finish this example off then, theta equals sine inverse of magnitude of V was 5, sine 150 divided by, we just found out magnitude of the resultant was 14.5. So now you go ahead and you calculate that. Divided by 14.5 and sine inverse, we get 9.9 degrees. All right. Therefore, this is a requirement. The resultant is 14.5 units. And we put our direction inside square brackets. So how would you describe its direction? You can do it a couple of ways. You could say that you went right 9.9 degrees up, or if you're comfortable with the east-west system, all right, up is north, and then we have our east, west, and south. You could write your final answer as east 9.9 degrees north, because it's above the x-axis, or you're turning to the left. I'm going to have to help some people with that in person to make sure they understand that. Okay, so a lot of extra work there. So I've got at least one more example, and to finish up the next video. We'll do it without the extras in there, so you can see how that works. But the key here, and the most important thing, is that head to tail writing. You need to put those vectors head to tail to be able to add and subtract vectors. After that, you use your cosine law, you use your sine law, and you're on your way to finishing the question. Okay? So keep that in mind, and I'll talk to you here in the next example. Cool.